All right, so since we're doing this like a scavenger hunt, I'm going to jump back and forth to the notes to kind of show where I'm finding this information so you know how to do that. So sine of x minus h shifts the graph of the sine function blank h units. So it's going to be right, left, up, down. So to look where to look for that is going to be in OneNote. Go to the Unit 1 notes, page 1. And we'll scroll down. All the transformation stuff's in the bottom left corner here. So we even have f of x minus h. So in this case, we've got sine of x minus h. So basically, f, the function, is sine in this case. So we can basically just copy this right here. It moves it right h units. So it's going to be right. And then let's see, cosine of x minus h. Notice that the minus h is outside of the parentheses. So then we're going to look back at the transformation rules again. So this is inside, so we're not using that anymore. So this is f of x plus k moves it up k units. F of x minus k moves it down k units. So in this case, we're going to go down h units. Let's see, fill in the blank, tangent of 0.5x. So does it horizontally shrink, horizontally stretch? So then we're going to go back to our notes. Notice when the multiplier is inside the parentheses, then it's going to be a horizontal dilation of 1 over whatever that number is, which means it shrinks if that's a bigger number than 1. If the number is less than 1, like if it's a fraction, like in this case it's 0.5, right? It means it's going to get bigger. It's going to horizontally stretch it. So the way I think about it is inside the parentheses, you always do the opposite. If you're adding or subtracting inside the parentheses, when you subtract, you move right, and when you add, you move left. It's the opposite of what you would think. And same with the multiplying. Multiplying inside the parentheses, if you multiply by a bigger number, it gets smaller. If you multiply by a smaller number, it gets bigger. So in this case, it's a number that's smaller than 1, so it's going to stretch it out horizontally. And then if the numbers are outside the parentheses, like, for example, this one, then it does what you think it's going to do. A bigger number is going to make it bigger. And it's always horizontal when you're inside the parentheses and vertical when you're outside. So a bigger number on the outside is going to stretch it. It's going to make it bigger vertically. And that is down here, vertical dilation of A. So this one has 2 answers, 0.5 times sine of 2x. So let's look again, 0.5 on the outside, 2 on the inside. So that 0.5 on the outside here is going to be a shrinking, right? If A is less than 1, so a smaller number on the outside makes it smaller. It makes sense. So it's going to be a vertical shrink. And then what does the 2 on the inside do? Bigger number on the inside means it gets smaller horizontally. It's the opposite of what we think. Horizontal shrinks. Oh yeah, this one's all janky. This is correct even though it says it's not. All right, I switched to the one with the right answers on it. So then moving to the next slide, we've got the point -3, 6. So let's look at our notes again, reminding us of the quadrants. This is something you learned probably when you were pretty young, but this is going to be coming in handy a lot this year. I've never taught a pre-calculus class where people didn't make mistakes on this because you just are working in all of them all the time. So you'll slip up and it's fine. But this is where the notes are on that. So quadrant 1 is positive, positive. Quadrant 2 is negative, positive. So negative x value, positive y value. It's going to be quadrant 2. This is negative x and negative y. So negative, negative is quadrant 3. Positive x, negative y. Positive, negative is quadrant 4. All right, now we're going to start doing a little calculations, right? So what is the area of a circle with diameter 3x? Hint, because x is a variable, your answer is going to be an equation because we could always plug in anything for x. So we've got a circle with diameter 3x. Remember, we can find it in here. The area of a circle is a equals pi r squared. So we've got a equals pi r squared. And then we don't know what r is, though, but we know what d is. This is the diameter, right? So the radius is half the diameter. So d equals 3x, r equals 1.5x. It's just half of d. So then we've got a equals pi times, this is going to be the important part where people will probably make mistakes. You have to square both parts of this because the radius is 1.5 times x, which means you're squaring 1.5 and x. 1.5x squared would be incorrect. So then, because of the distribution of exponents, right? So then you could rewrite this as 1.5 pi x squared or something like that, and that would get you the correct answer. What? Oh, I didn't square my 1.5. Next one. All right, so what is the perimeter of a circle with the diameter 5x? Similar but different equation, right? So the perimeter of a circle, same place in the notes, perimeter equals 2 pi r. 2 pi r. So then we don't know r again, but we can figure it out. If d equals 5x, then r equals 2.5x. So p equals 2 times 2.5x times pi, which equals 5x pi. You can put those numbers in any order. All right, a triangle is shown. What is the value of A? What is this leg next to the 30 degrees? Now remembering that this is the right angle, so opposite the right angle is the hypotenuse. Then we're looking at 30 degrees and we're trying to find A. The A is the adjacent leg to this angle, right? Adjacent, and we have the hypotenuse. So if we remember SOHCAHTOA, CAH is cosine is adjacent over hypotenuse. And again, that is in your notes here if you need a reminder. So cosine equals adjacent over hypotenuse. We've got cosine of 30 equals A over the square root of 3. Now we just need to do a little algebra. In fact, it's just one step. We're going to multiply both sides by the square root of 3. Just to get rid of this square root of 3 here. These two cancel. And then you have A equals square root of 3 times cosine of 30. Cosine of 30 is the square root of 3 over 2. So that equals square root of 3 times the square root of 3 over 2. Square root of 3 times the square root of 3, that's just 3. So it equals 3 over 2, or 1.5. There you go. And two more, right triangle. So similarly, we're dealing with a 30-degree angle. This time we're looking at the side that is opposite the angle. So opposite over hypotenuse being 40. The side opposite the angle, it's across the triangle, is A. So we're going to use sine because sine is opposite over hypotenuse. And just a reminder, that is right here in case you need to look for it at any point. So we've got the sine of 30 degrees equals A over 40. I know for a fact that the sine of 30 is 1/2. So if that equals A over 40, then A must equal 20. 20 over 40 is the same as 1 over 2. Quick note that you should definitely remember because it's going to come up this whole semester. Always check your calculator to see it's in the right mode. In this case, you want it to be in the degree mode. If you're using a TI calculator, you can hit mode and change that. If you're using Desmos, you change it on the wrench on the right side. Last one, right triangle is shown. What is the value of x? These are angles that I can't just tell you off the top of my head what the cosine or sine is, but that's okay. There's two ways to do this because we have two different angles. So I will show you both. We can use, we're doing 12 over x, right? It's going to be the sine of 49 is 12 over x because it's opposite, 12 is opposite 49. The cosine of 41 is also 12 over x because it's adjacent to the 12. So we've got these two equations. They're going to come out the same because these two things are equal to each other, sine of 49 and cosine of 41. So I'm just going to solve one of them, but basically what you would do is you'd multiply both sides by x. X times the cosine of 41 degrees equals 12 over x times x. X's cancel. Then we would divide both sides by cosine of 41, right? Because we want to get the x by itself. So then these two cosines cancel out, and then you have 12 over the cosine of 41. So then this is something you're going to have to plug into a calculator because nobody knows the cosine of 41 off the top of their head. But when you plug it in, make sure you're in the degree mode, or you will get this wrong like I did the first time I did this. And then you'll get like 15.9 is what you'll get. And you'll get it the same if you do sine of 49 or cosine 41 there. So we've got 15.9 right here. Submit, and we're done.